We saw last time how TCP implements flow control, that is, making sure that the sender on a connection does not overwhelm the receiver end of the connection. TCP does this by having a window field in the TCP header, which here we're going to call the RWIND field, or receiver window field. That is, that's how much data that the receiving end of a connection is able to immediately accept. No point sending more than that data to it right now. And we'll call window the window size for the sending buffer. So we'll keep window no greater than the receiving window. Again, no point trying to send more than can be accepted. There's a corner case where our wind goes to 0 because our end is not ready for anything and we still have to send 1 byte of data, but we'll just ignore that for now and say that the window is always less than or equal to the receiving window. Congestion control, again, a different goal, not to avoid overwhelming the receiving end of a connection, but to avoid overwhelming the network in between the sender and receiver. So we will use cwind as the name of that maximal value that the network can accommodate. And we keep our sender's window less than or equal to that as well. So our window size is going to be the minimum of how much the network can accommodate and how much the specific receiver can accommodate. RWIND is given to us, cwind we're going to have to figure out as part of the TCP protocol. And here's how it works. We start cwind at a maximum segment size, or MSS. This is a value that's configured in the operating system and based on what kind of network that machine is plugged into. It's a property of the network in the sense that there's an expectation that all devices in between the sender and the receiver can support a packet that has a segment of at least MSS size. These days, MSS is almost always around 1.5K. So that's the maximum segment size. Remember that segment is the TCP header plus its payload. So the actual amount of data is going to be slightly less than that 1.5K value, but still, again, close to 1.5K because the TCP header is not that big. So that's just an initial guess, but then cwind is going to grow until some other parameter, SS thresh, which start large, but we're going to adapt SSH thresh as well as cwind in this protocol. SSH thresh typically starts at around 64K. So between 1.5K and 64K, the expectation is that the right congestion control window is somewhere in between there, but it's not going to be bounded by those initial lower and upper bounds. The upper bound SSH thresh will also adapt based on what the connection sees.